Hello, I am Olale Badmos and this is my YouTube channel. So here you will get mathematics and science lesson videos, difficult concepts made easy through well explained and thorough methods of teaching. To get notifications from this channel, subscribe, like and share. Share to your neighbors, share to your friends, share to that student, share even as a parent to other parents, alright, who have students and children in secondary education. I want to assure you that you are going to get lessons that appeal to the understanding of your words, of your children, of your students, and even you as a student. Thank you. The second theorem, still under cyclic quadrilateral. So here, so let's say we have an external angle. Let's call this angle Z. So let's say we have an external angle, right? This angle, the angle at Z or the angle Z, is external to the cyclic quadrilateral. Is external to the cyclic quadrilateral. Alright, so what is the implication of this? So let me also label this angle, let's call it angle T. Right, angle T. So I will also need to apply basic geometry theorems here. Alright, so first thing is that from what we can see, we see that T plus Z is equal to 180 degrees. This is the sum of angles on a straight line. The sum of angles on a straight line. Now you must have been taught before, right, how that a straight angle is 180 degrees. A straight angle is 180 degrees. So anytime you have angles clustered on a straight line, right, the sum of all of those angles, right, is 180 degrees. Is 180 degrees. So the angle at T, is BCD. All right. So let's just let's write it this way. Angle BCD, right? The angle at Z is DC. Let's call this E, right? Is DCE, DCE, right? So the angle BCD, which is T, and the angle DCE, which is Z, is equal to 180 degrees, right? And the reason is that the sum of angles on a straight line is equal to 180 degrees. The sum of angles on a straight line is equal to 180 degrees. Now there's another thing to also take note of. Now you see that the angle T, right, as we have done before, which is the angle BCD, right, is equal, BAD, the sum of T, right, and the angle at A is equal to 180 degrees. We've done that before, which is that the opposite angles of a cyclic quadrilateral is also equal to 180 degrees. So let us put that down. So we write BCD, the angle BCD, right, which is the angle T, plus angle BAD. BAD is equal to 180 degrees. What's the reason? Opposite angles of cyclic quadrilateral, right, is equal to 180 degrees. That's what we proved before. So angle BCD and plus angle BAD is equal to 180 degrees. Now take note that if angle BCD, right, and angle DCE is 180 degrees, that's the sum of BCD and DCE is 180 degrees, then BCD plus BAD is also what, 180 degrees. Right? What that means is that BAD, right, angle BAD and DCE, right, are what? Are the same. They are the same, right? Again, I'll take that again. If angle BCD plus angle DCE, the sum of the two of them equals 180 degrees, right? 180 degrees, and the reason is the sum of angles on a straight line, right, is 180 degrees. Then also we've been able to find that angle BCD plus BAD is also 180 degrees, right? Is also 180 degrees. What that means is that angle BAD and DCE they are what? They are equal. They are equal. So let's see how we can put this in writing. BCD, angle BCD plus angle DCE. Now, so this, all right, is equal to this because this is 180 degrees, right? This is also 180 degrees. So let's equate both of them. We can call them equations 1 and 2, right? We can say this is equation 1, right? And this is equation 2. So what we are doing here is to equate equation 1 and 2 because both of them are the same. They are equal to 180 degrees. So equate both of them. BCD plus DCE is 180. BCD plus BAD is also 180. BCD plus BAD is also 180 degrees. So if we simplify this, right, collect like terms. So angle BCD minus angle BCD on the other side. This comes to this side, becomes minus, right? And that's of course, let's continue. So we say have DCE on this side plus DCE, and that's equal to angle BAD. Angle BAD. So BCD minus BCD, right, we give 0. So we are left with angle DCE, all right, which is equal to angle BAD, right? Angle DCE, angle DC, where's DCE, which is the angle at Z, right, is equal to angle BAD. So let's put that properly. So as we have it there, DCE is Z, all right, is equal to angle BAD. Angle BAD. So how do we write this in words? We'll say that therefore the exterior angle, exterior means outside, the exterior angle of a cyclic quadrilateral, the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. I hope this is clear now. So from here, we'll begin to take applied questions. So let's see 1 or 2 applied questions. So here we have an example. In the diagram below, O is the center of the circle. Now line BOC is a diameter. A diameter is a line that divides the circle into 2 equal halves. So it's a diameter. Then angle ADC is 37 degrees. So we have the angle here. Angle ADC is 37 degrees. So we have to calculate angle ACB. The angle here is what we are calculating. So let this be X, right? Let the angle ACB be X. Now, what do we notice? Now, one thing about geometry is once you know your theorems, there's no need for long calculations. Now, first thing is that we can see that BAC or ABC is a triangle. All right. So first thing to take note of, ABC is a triangle. Now we can also notice that angle BAC is a right angle, 90 degrees. Is a right angle, right? Is a right angle. The angle here is a right angle. That's 90 degrees, right? And don't forget, we are looking for the angle X. That's angle ACB. Now, one thing, so we have the angle at A, right? BAC 90 degrees. We're looking for angle ACB. That's the angle X. So how then do we find the angle at B? That's the angle ABC. Very simple. So you take note of this angle at D, 37 degrees. Now when you take note of the two of them, you will see that they are in the same segment. They are in the same segment, and we have proved this before, that angles, right, found in the same segment are equal. So here we are going to write CDA or ADC, angle ADC, right, is equal to angle ABC, and that's equal to 37 degrees. And you must always write your reason: angles in the same segment. Angles in the same segment. Angles in the same segment. Alright? So that means this is also 37 degrees. Right? ABC is also 37 degrees. So to find the angle X, right, how do we do that? Now, so pay attention to this. So we say that consider triangle ABC. Consider triangle ABC. So let's pick out the three angles there. BAC is an angle in the triangle, plus ABC, that's another angle, plus the third angle, which is what we're looking for, ACB, and the three, right, the sum of the three equals 180 degrees. What's the reason? Sum of angles in a triangle. Sum of angles in a triangle. Sum of angles in a triangle. So what is BAC? BAC is 90. What is ABC? Is 37 degrees, right? Plus the angle at ACB, the angle ACB X, and that's equal to 180 degrees. So what is 90 plus 37? We add this together, then we subtract it from 180 to find the value of X. 90 plus 37 is 127 degrees, plus X is equal to 180 degrees. Alright, so X is equal to 180 degrees minus 127 degrees. Alright, so that will give us 53. So therefore, angle ACB, right? Angle ACB is equal to 53 degrees. So once you know how to apply your theorems, right, properly, you know how to solve any questions on circle geometry. Alright, so I hope that lesson was effective enough to help your understanding and to help you learn better. I want to believe that you've gotten better than before. So if you have not subscribed, do well to do that. Subscribe, like, and share. Share to everyone around you so you can get more notifications. Thank you. Bye.